This session is about DevOps 2.0, programmed by Digitarati, India's first IT finishing school.
We have designed this session keeping into view everybody, because DevOps 2.0 is about everybody. So let's get into it. So let me set up the context. The context is the following. I do not know how many of you know that our entire world's population is almost 7.83 billion, right? Considering the urbanization factor of 56.4%. Now imagine that this, let me just hide this. This population, there are 66.6% people, which is almost 2 by 3rd, which are the mobile users. And out of that, there are 4.66 out of 7.83, which are internet users, which are actively using internet. And then there are 4.20 billion of the users who are rather, people around the world who are actually active on social media users. Now, why am I saying that, right? This has nothing to do with the DevOps world. So see, understand, before we start understanding the technology, it is very, very important to understand the business context. And the business context can be very, very clearly defined by defining out the demand part. And this is the demand part. So you can imagine that 59% of the people are actually on internet. That means that they are actively using internet. That means they are, they in some or the other form are connected to WhatsApp or, to Step or the different kind of media. So that is where this whole, large majority of the population is available on internet. And it is one of the recent surveys. So hence, this is not obsolete. Now, what is in it for us? Why do I bother about it? So here is the answer. If there is a huge people available on internet, that definitely makes a lot of business sense to then prepare something where while they are being on internet, they can also help you getting some business. And that is where this whole pace of software development is moving so faster than ever. If you can imagine, 94% of the organizations are practicing agile over waterfall, which was so long back, and we'll talk about it in a minute. There are 70 to 71% of the organizations that are planning for having either they have an active DevOps initiative or they are planning it in next 12 months. And then if you compare the number of code deployment, for the people who do not know about this, any kind of feature that you see on an app is then being backed up by a code, right? So then the number of code deployment that are happening on a large organization versus a short or a small organization, this is 46 times lesser. So imagine that how this whole demand of 56+% of the users is being catered by the software industry, and it is growing every now and then, right? So this is then the supply part, that you have the whole lot of players available into the market who are harping on becoming more agile, harping on becoming more DevOps oriented, and harping on increasing the number of code deployment every day, every now and then to become more efficient, become more customer centric, and so on and so forth, right? So this then sets up the context that okay, so we have a business case, we have the number of users, and we have the organizations who are taking care of it. Now what's next? Here is an interesting metric. As you would know, for using any feature of an app, the first thing that you need to do is install an application on your mobile. But here is the little sad part of the story, that this was a recent survey which was being done. What it says that there are almost 30 to 35% of the user who uninstall the app within 1 or 2 days of installing it. And I'm sure a lot of you would also agree to that, and we all do that. We are looking out for some specific solution or maybe some specific knowledge or some specific help, and then we install, or maybe even changing our behaviors for that matter, and then we install an app, but then we we really uninstall that app because of some top reasons. And why I have encircled the three reasons, because this is really very much relevant to the context that we are going to talk about today. So a lot of users usually uninstall the app because the UI, which is the user interface of the app, does not looks very promising, does not looks very jazzy, does not looks very user friendly, and it is 42% amongst those 30 to 35%. Lot of users, which is close to 48%, uninstall the app because their application performance sucks. It usually gets stuck at it, it does not move forward, and hence there is this slow performance. Another area is that there are a lot of apps where there is a complex registration process, right? Instead of using features of using a sign-on from Google, Facebook, and all that, they wants to get a lot of information from the users in the first place, and hence users usually do not like it, and then they uninstall that app, and which is amounts to 68%. So if you total that up, almost more than 75% of the reasons of why a user will uninstall an app is because he is ending up in not getting a very great experience from that app, either in the form of UI UX not perform, application not performing, meeting the minimum performance criteria, or the complex registration. I've not included the annoying notifications, but in some other way that is related to the business model of a lot of organizations, where the whole advertisement bit of it is basically their bread and butter. So hence that is something couple of times not an option which they can get rid of it. So we identified that a lot of that business demand side of this is being addressed by the supply. The supply is usually coming from the organizations which are agile and making more codes than their competitors, or making their code which is with the people who are fairly new into the market. And then typically we now see that how the users who are the end beneficiary of these supplies are now there is a bigger problem that they kind of get rid of their app within 2 to 3 or 3 to 4 days of installing, and the reason is bad UI, the application performance, and the complex registration process, which is typically around 75 to 80% of the overall reasons why an user will uninstall it. Now let's look at the solution part. So where there is a problem, there is always a solution. It might not be able to address it 100%, but of course there had been a great push to get a solution. So here are some ways on how traditionally organizations have tried to address this challenge of getting more user centric and meeting their demands of getting rid of these issues in the past. As you would all know, people who have started their professional journey earlier and have got an opportunity to work in some of those waterfall projects. So waterfall is typically like a waterfall, where if the water is fallen, it cannot be rolled back. And so is the waterfall methodology. So, the design of how the application has to be structured is made, and then that's a decision point. The customer signs it off. Yes, this is all good. And then they start coding. And then right after the entire coding is complete, then there is a decision point whether it is good, bad, or not. And because of this whole reason, the software development world was not having more than 40 to 30 to 45% of success, because the entire coding has happened, and then possibly the testing was made, and then the deployments were there. So a lot of times people used to say that in production the code has been burst, or the production was not successful. So that was the first step taken to address this challenge. This does not really worked out because this does not had a lot of customer centricity. And then we moved on towards the another area, which was agile. The focus is then on bringing in more customer centricity. So we thought that rather than deploying everything end to end, let's break it into chunks, right? Maybe do it via a little iterative way, as one feature, one code, and then testing, and then get a sign off, and then move on. This was really great because then you have came up with an idea of how do you make a scrum, how do you basically ensure that there is sign off from the customer at every stage, and hence the failure has drastically reduced. Now, this was typically, I would say, a process view. Then what we identified that's great, but then the other form was of DevOps. Now, the whole irony of development team, or basically the tussle. Sorry for using that word, but I cannot really use another word to define that scenario. Think about a development team. The development team is always and always focused on bringing in new features into the app because that's what they wanted to do. But the operations team usually do not like or rather, you did not really like the attitude of development team, that they are focusing too much on change. The reason being, for operations, there was a lot of instability, right? As and when a new feature comes in, these guys used to get a lot of tickets, the operations team, and hence there was this whole tussle between the two, where one resisted the other's way of working, and hence this somebody intelligent thought about this idea that let's bring both these together, and hence this word DevOps, or rather this engineering practice DevOps, was being formed, wherein you wanted to kind of introduce the concepts like your continuous integration, right, where you do a branching, you bring out continuous integration, continuous deployment, and then you introduce a lot of automation so that you can see things running in parallel, and then people collaborated more to make it work. And in a way, there were a lot of challenges that we saw earlier were addressed, that the time to market for most of the organizations has reduced a lot. The second part is basically the efficiency has increased a lot, the collaboration between the team has increased a lot, and hence there were really great outcomes that we saw at the end of DevOps. But then let's also look at some of those. We'll go a little bit more detail. So we talked about the operations team, we talked about development team, but we missed to talk about a QA, right? So QA is a team who typically is sitting right after I would say between the development and operations team. So when some development team usually get the requirement, they do the coding, and then they kind of do a deployment, then possibly the QA team would really come in, and then they'll start testing from a user point of view. So these guys usually wear the lens and hats of the users, and then they will start testing. And then the focus is basically more about how would these features would look like. So they will have all their use cases in terms of how do they test it, and then they basically drill it down towards the end of in terms of identifying from a user perspective that this is how a feature would get into a result. And then if they identified something which is an issue, then they report it back to the development team for getting that fixed, right? And there may be different ways and methodologies on how do they do it. Some may be raising a bug, or some may be reporting it out over an email. So a couple of quick feature sets that were introduced as a part of DevOps system is the following. There was a whole idea of continuous integration, right? So by continuous integration, we mean that there is this whole code main branch. People across the team are being identified, and they are being allocated different tasks, and they are being given another piece of branch which they would like to kind of work on from a coding perspective, and then that code will get reviewed maybe with somebody who is a reviewer, and then that code would really get merged to the main code right after all those things are complete. So that was something that was not there in waterfall and was introduced. There was a version control system, so it's self-explanatory. You can have a control over the releases. You can actually look into the lens from analytics. You can identify what is a problem. So for example, you see that there are certain bottlenecks, so certain deployments frequency is higher than others. Then you can really identify what is the reason of why your time to market or your production release is getting delayed, and you can fix it. You can also identify some of those things, for example, from a performance specification, looking into the lead time for change, the change failure rate, and maybe the feedbacks from QA, which then typically decide the performance, right? And then typically a couple of things which were more about how do you, because now you're bringing two teams together, which is more of a cultural change than a technology change. So how does the continuous communication happens, right? And then how do the life cycle coordination happens? What are the typical feedback loops? how if somebody identifies, how they report it back. So these were certain interesting things that were developed during DevOps era, and then they were effectively introduced and implemented. But then there is always an opportunity for improvement, and so was in DevOps. So one of those key learnings that existed was the DevOps was very, very limited in terms of the metrics, right? So some of those metrics that they introduced was typically in terms of the deployment frequencies, the lead time for change, MTTR, change failure rates. But if a coder is usually working on a module, then possibly can he use something from the library? That real-time feedback really did not exist, right? Or maybe in the other point that talks about is the limited customer feedback. You might be getting too technical about developing your code and then merging it to your main branch and things like that. But then how does it reflect as an end user experience? That was not known, right? In DevOps part. The third part, which is very important, while you create your pipeline, right? You would not have a view, what is the business value that you would see in that pipeline? And this is very, very important. Because if you recall, we started with a problem statement of that there is a huge population. There are a lot of people onto the internet. So they have a choice. They have a choice of sticking to your app, or they have a choice to switch to other app, right? So hence, if you have not very, very clearly articulated the business value into your entire way you work and you collaborate, then you would really fail to deliver the outcome, because technology outcome would then be has to kind of some or the other way linked to the business outcome. And if at all it is not linked, then the job is not done. So by looking at this, so what is missing? That here is the problem. The problem is that in everything that we are doing, we are missing users. We are trying to solve a technology problem, right? But believe me, the user is the end beneficiary. And until and unless we don't think from the lens of the user, we are likely not to get to solve their problem. I mean, in order to solve the problem that you called out, I need to speak to you. How would a product manager would know about everything that I talked about, right? How would a product manager would know that my colleagues in, let's say, some part of Japan or Australia or maybe India, they have these as a preferences. So that bit is one of the reason, in a nutshell, which is largely missing. So then see, I mean, do we have a solution, or I'm just here to talk about the problem? No, we do. And the solution is the following. So the way I look at the more evolved form of DevOps is BizDevOps. And I'm sure a lot of you would have really know this, that we are now looking at the business angle, because business to me is the user, right? And until and unless I do not consider them while I'll do the development or while I'll do the operations, I'm likely not being able to solve their problem. And this is DevOps 2.0, my dear friends. You needed to bring in the business stakeholders into the DevOps in order to confidently validate the business processes, which works end to end across single or multiple applications. And this is the new era. Until and unless you are not focused on your customer in terms of every processes that you create, in terms of every technology that you create, in terms of every outcome that you define, in terms of every scrum calls that you have. If the outcome is not user-centric, then the results might not be that great as it would be while you bring that user lens. And this is what we're going to focus on in next 90 minutes, that this is the new era. So how do we, so let's then talk about, because a lot of times, we talked about that before we implement anything, we always do a comparison. And I think, don't get offended, but this is the human nature. We always compare, right? And we identify, we kind of try to get an answer to only one question: what is in it for me? So I talked about users, that's fine, right? And all of you would say, boss, this is too technically complex. Now Ashish is here, and he will, create further more complexity to my already complex pipeline. That is not the purpose. So let's talk about how can we create a success story, and how have some other organizations like you all would have really made a difference. So I spoke to a couple of my colleagues at Barclays, And here is what they have done. The challenge was almost the same that we spoke about in last couple of minutes, that it was very difficult for them to keep the pace of the market, and more importantly, keep the pace of the segmented user groups. User group is very segmented. Some of them would really harper on one set of features, some of them would harper on the other set of features. And now with the way and with the pace, at least the banking industry is focusing more on the mobile banking and likes, right? So that was the challenge. And the solution was that they modernized the technology, but more importantly, the culture. And how have they done that? We'll talk about in a second. So the first thing that they did was they have brought the entire business in the DevOps. That means currently the definition of the DevOps was only limited to the development and operations and the QA team, but now HR team, the auditing team, the security team, the compliance team, the whole investment banking application team, and the whole retail bank was actually part of the DevOps cycle. And we will see in detail then how was it important, how was it done. But this is the new definition of DevOps, that you have to involve everybody. If you do not involve everybody into the organization, because these are the guys, right? Think about the marketing team who really touches base with the users. Thinks about the sales team who usually touch base with the users, right? So if we do not involve them into this development process, then we will miss out that intel which a user needs and which has to get then coded or codified into your app, and hence it has to become more user-centric. So they literally did this. It took them 18 months to bring that culture. They have also partnered with a lot of organizations in the form of a lot of organizations, and I just don't want to talk about that. But then what is the impact? Because ultimately you have to also see the impact. Their code deployment time, which was 56 days, was reduced to 28 days. And the reason why, because then they identified the right set of use cases which a quality analyst has to look at, not just bother too much about the code coverage and then include everything that is needed. Second thing, what as I talked about, is that they have reduced the time to market, because now you're seeing that in the entire life cycle of SDLC, the biggest component is coding. Right? Your requirement gathering is a smaller component and a smaller quadrant. Your coding is one of the biggest quadrant because it takes that massive amount of time. And then your QA, and then maybe your production deployment, which would automatically happen as a part of your pipeline, and maybe after some testing. So then that component was reduced, and then they became more competitive, because then if they think about a feature, then they are able to deploy it much ahead than their competitor and able to gain that edge. That has also facilitated their journey to cloud. I'll talk about it, maybe in little detail, that they were being able to build up their private cloud within the organization. The time that was taking for provisioning a VM, right, which was earlier taking like 3 to 4 days, was basically done on a click of a button. Like, it was giving a similar experience as you can probably, go and do an S3 configuration, or maybe a VM configuration into the likes of Amazon or Google or maybe Azure, right? So hence they identified very, very clearly that for these set of applications, there is these kind of VMs or these kind of infrastructure provisioning that has to happen, and have completely automated it by bringing in Kubernetes, by bringing in Terraforms of the world, and make that possible. The fourth thing, which is very, very important, is the awareness bit, right? Assuming an organization as big as Barclays, what are the typical challenges that they would have to face to train everybody and bring everybody into the same set of same thought process? And that is where they have created different communities of practice. We sometimes also call it center of excellence within the organizations, where they had created volunteers. Because typically if you try to address this by a manager team relationship, it would not get addressed, dear friend. You need to think through that in manager and client relationship, most of the time it is a push-pull model, but you need to create more of a pull model than a push model. And hence the awareness and the training was the fifth thing that they've taken, and the results were very, very pretty evident. And hence They now claim to be one of the largest and fastest agile deployment organizations. So this is the impact that they could bring in, right? So before we talk about technological changes, before we talk about the process changes, you need to understand what would be my outcome looks like. And this is the kind of outcome. And I'm sure all of you who are really part of the development team would really want to see this as an outcome. If you're able to reduce your time to market, if you're able to reduce the time you are taking to deploy it into the production, nothing like it. But that being said, that does not mean that you double the size of the defects that you're getting, right? So that's not the, I would say, that's not the balance that we are talking about. We are talking about that you continue to reduce your number of defects, you continue to increase the stability of your applications, you continue to ensure that you increase the experience of the user, and at the same time, by bringing in all that together, you are also able to reduce your time to market, which has a lot of business benefit. So this was, I would say, amongst every other organizations, in the similar organizations like you all are in, this is one of the use case, this is one of the case study, which is very, very important for you to look at it. Now, as we move on, now we will take the technology lens, right? See, because if you'll start with technology, 50% of you will start yawning on Monday morning, right? And hence we do not want it to start with technology. So now let's look at what would change in DevOps. And I'm going to talk very, very clearly now in terms of, couple of things which might be relevant for the people who are really working on this. So earlier, as you could see, that DevOps 1.0 was encircled and focused only on the operations, QA, and development team, but now it involves everybody. It involves product manager, it involves the product team, which is the team which is interfacing the clients, it involves the business, it involves the sales team, and it involves the marketing team. Because without all these teams including into it, you will not be able to get the customer centricity. That is for sure. And we'll talk about some of those examples on how we can make that possible. Now, a couple of principles. One thing is very important, and I think somebody talked about it, that some people want reward and some people don't want reward, but they don't want it to compromise onto the user experience that they're getting. They don't want to compromise on the value that they're getting from the case. So then that means that there is a user segmentation. By user segmentation, what I meant is that there are different group of people who are having a different set of requirements from an application. So when you are thinking about rolling an app, you usually think about the entire world as a group of users, right? Or maybe your X number of users. We usually don't really think about that. Hey, listen, my user is broken into multiple different segments, and hence I needed to have that I can do a feature rollout only for feature, users for which that feature is relevant. This can be possible in DevOps 2.0. And how do we do this? By using features like, for example, toggling features, which allows your code to be turned on and off for a specific set of users. This can be made possible. Continuous delivery is a takeaway which continues to exist, but then this is in context to the decoupling the features from the code deployment. That means for your specific set of user segments, you can continue to do a continuous delivery. Now this whole everything is centered around user, and hence the third principle is very important, that you need to have user-central deployments. If you are not doing a user-central deployment, then the likelihood of you getting solving that problem is really less. The last is very important. Typically, a lot of organizations still consider the entire group of people working on IT as an IT team, and they consider them to be technical. And then there are this sort of bifurcation within an organization, that these are technical users, these are non-technical users, right? Here, it is very, very important that we need to combine them together, and hence non-technical and technical, there is this addition sign in between. They have to come together. If they are not coming together, then we'll not be able to solve the challenges that we saw earlier. Customer feedback is very important, and I'll talk about it in a second, that how can we make that happen. Risk mitigation is important, which was always there in DevOps 1.0, but now since you have the focused user groups for which you're doing some feature rollout, then you need to ensure that you solve the problem of risk. For example, the PII can be one risk, which is personally identifiable information, and some bit of it, maybe the how do you solve the problem of, let's say, somebody talked about that it is really, taking or eating a lot of my mobile resources in the form of memory processing and all that. So how do you make it let's say, little less heavy than it can be, or maybe make a light application, and then possibly make it more iterative, which is, carry forward way of how do we do it in agile. But these are, some of those focus areas of principles which are now have to be focused on 2.0. And largely, if you read all of them, 80 to 90% of them are user centric. Very few are very technically focused, and this is, my dear friends, is the focus of DevOps 2.0, right? So I will give you a little bit more lens of how do you think this would work when I say bringing everything together. So understand, if your marketing team is also aware of how you are creating code, what do you consider as, maybe a user story or maybe a task into Jira, and then you start coding, and how do you do unit testing, how do you do a CI/CD, how do you do QA, then they understand this whole part. And it is very important for them to understand that, because once they are the front facing team, business, sales and marketing, who actually engages with the customer. So I'm thinking about an hypothetical situation here, that in this situation, your customer is able to, or rather your business, sales and marketing team is able to identify the requirements from the customer by doing a design thinking, maybe approach. And design thinking approach can be as simple as, they do a discovery, during their discussion, they have some set of questions which they ask, and then based on those questions, they maybe build up a small design, right? That this is, is this something which would really help you getting rid of your current problem? Because I'm sure that they will hear a lot of their issues from the clients while they go and talk to them, over a regular or maybe over a discussion. Now, once they have this view, then they can basically pass this on to the development team, which is their intel. And then this development team usually, which basically focuses on the entire coding and all that activity. Then after, they do this development, then the quality gate for the QA team is that, they do an A/B testing, right? Which essentially means that they will create two products, maybe A and then B, and then they will test it out to ensure that they are not falling trap of, not resolving some of those problems. And then the rest of the part was basically a continuation of DevOps 1.0, where regularly, the QA team would then hand it over to the operations team. And if you look at the entire life cycle of DevOps 2.0, which is the bottom picture. So how would they do the toggling feature, right? How would they turn off some of those features because they are made for some specific user group over the others? So that's where they needed to focus on a flag driven development, right? Once they do a flag driven development during the process of coding, this basically rollout of features to a specific user group can then be controlled by the business and sales marketing team. You do not have to always have a development team doing it, right? And while we will do a demo, we will also give you a slight view on how this is possible. So if you could see, the DevOps 1.0 was basically the team, the plan, the code, the test and deploy, and then we stopped. There's nothing further. But now there are two more steps that are added. What has added? The rollout is happening for specific segments, right? Some rollouts, some features are needed for 100% of the users. Some rollout is happening for 50%, and some of them is basically happening for the 20%. And then the important part, which is why our whole app uninstallation problem existed, that there is this fast feedback. And I'll talk about it, how this can be made possible. But if you, just have a look and then visualize this picture into the mind even after the session, then you would imagine that this slide talks a lot about the how part, right? Rather than the what part. What part we already covered in the last session, rather last pages. And if we are able to crack this, then basically this is then called as BizDevOps or DevOps 2.0, right? I'll keep on moving. Please stop me when you have a question. Now I will say that while we will do this, let's look at the reimagined journeys of a couple of people into our organizations. How will it look like? What are those additional tasks that they needed to do now? So you can imagine that maybe our UI UX people, right, who usually do mockups or who usually create designs, now because of user now their user testing, which was typically on one simple prototype or one simple design, which was of course not user, it was not tested by users, can now be tested by the end users. The designers have to do this toggling experiment of testing it with those target group, and hence some of the issues that you have mentioned, personalization, I remember it correctly, would get addressed here, because right after you create a UI, you can't, and you do the get done with the coding, you can't come over and then do a rebuild the UI, right? So that is the time where you needed to do. And with this whole approach and focus of toggling experimentation, that is very easy to get it. Think about a marketing team. Now, marketing team, right, when they go and talk to the team, they can usually run this into beta phases, and they can run these through the some of those groups, and maybe using an iPod or something, right? iPad or something, they kind of give and ask the users to look at it while they are going ahead and speaking to their clients, or maybe the users of their client, and then basically get some real-time feedback. And hence there is this fast feedback time. So you're using it for the beta testing with the real users. That does not exist today. Product team can see their features before the release. So they are of course eyes and ears of the users for us, but they are not the real users. But then once they go and test it out to the real users, I'll tell you the bigger problem that will get addressed. A lot of times the requirements are not very clear when we go and talk about, and I would not say 100% of the cases, maybe 20 to 30% of the cases, and hence you see that there are incremental requirements that you get, when you're doing the development. So once the product team is super clear that these are the user stories which are needed even at that phase before the release, then believe me, you get a sense of all the user stories. At least 95% of the coverage existed, and hence the chances of you reworking on it, rebuilding it, retesting it, and resolving those complex technical problems, that get addressed a lot. And this would really help you to reduce your deployment cycle, right? Then the last but not the least, it's easy for developers, because while they're doing the development, they can flag the code so that in logical chunks it can then get accumulated, and hence a feature toggling can make it possible. So these are some reimagined journeys. I would not say that there is a whole lot of effort. It would really help, because a lot of times, at least I've seen that my sales team was completely non-technical. They know a lot about users. They can give a lot about users, but if you ask them what is the specific features that the users is looking for, they will be completely point blank, right? They would know about their business for sure. So that's where I think that whole encompassing everybody and making it leveraged by everybody in the organization is the difference, is the change that we can bring in by the journey of DevOps 2.0, right? Now, the benefits are, of course, I should not call it out, but of course, they are known by the way we have discussed. There is an opportunity of quick scaling, because you then understand your specific user target segment group, and you are able to identify what is that thing that really work for them. Does the personalization works for them, then the cost? Does the reward work for them, then the performance? Or does the performance work for them, then maybe a free license, right? So those are the things are very clear to you, and hence with that clear view, you are able to then scale up the features, and then maybe take that further. The stability of the system, of course, is great, because imagine that you get a lot of requirement as new user stories while you are done with 70 to 80% of your development work. That is really very painful, and hence your stability of the system increases a lot. The integrity of the application is not roll out, because you then are still stick to your original plan. The other benefit is that you are able to bring everybody together, right? So the DevOps is then not just defining it to be the development operations and the QA team, but it is the entire organization, and in a way it is encompassing the users. Business stakeholders, this is what I talked about, that your releases to the to the users not necessarily needed to be controlled by your developers. You can always create a view wherein you can always create some specific features available for users, and which can then be used by business to start off, turn off, and turn it on. so that they can get it directly tested by the users directly, right? So this was the quick benefit that I could think of, and I'm sure there will be a lot more. Now let's look at, okay, we talked about great things, we talked about great roadmap of how do we make it, but you would wanted to know what are those specific capabilities that you would need in order to make sure that you are able to deliver this, right? This is very important, right? Because if I do not talk about it, then that means then I would also be not be user centric, right? Guys, I'm keep on going. I'm sorry, we're a little time crunch with just 2 hours for this session. So please interrupt me, ask me if there are any questions. Otherwise, I'll keep going. So typically when I talk about the new capabilities, the capabilities have to be bucketed under three different verticals. Vertical one would be what are the organization specific changes that we need to do. That's where our business leaders have to intervene. What are the technology related interventions that we need to do, which is where our technology architects have to take care of. And then the third is basically the process lens, which is where either the person who is in charge of the process or the process owners have to come into place. Now I'll pick a couple of them because some of them are really self-explanatory to give you a sense. So first is your service-oriented organization. We all are living in the era of API. Now, a lot of times specific features, specific product features for us to demo to the different departments and team, these kind of requests as well as service happens or the transactions happens over email, right? So we are talking about a world where in DevOps 2.0, you are talking about an API based architecture where anybody into the organizations using an API can get access to some of those features and can then use it for a specific targeted user segment testing. That is one thing which is very, very important. If you do not do it, then you will waste a lot of time into this manual coordination. So you have to think about this as a target while you're starting with the development, so that at any point of time, this is what as a part of your pipeline is something which is accessible, and this is what can be used, right? So that's where this service-oriented organization is all about. Cross-functional teams. So here a little bit deviation in the way we work. There is a lot of focus on multi-skilling, right? Where you needed to look out for people who are having experience and technology focus on 10 different technologies. I think in this particular area, it is more about the specialization, because if you do not have a deep expertise or a deep specialization on one topic, then the way you would mature a technology to be more suited for delivering a user experience would really not be able to serve that purpose. So hence a cross-functional team, a small team like the agile team, and then basically talking about a functional and a non-functional team, and maybe a technical and a functional team combination is important, and that is what has to be taken care of. A DevOps culture cannot really come into effect until and unless the service-oriented organization or maybe a cross-functional team exists. And in addition, you needed to have a team which typically owns the microservice platform, a CI/CD platform, and then last but not the least, the service reliability or the site reliability engineering, the SRE part. See, SRE culture has a lot of benefits, and one benefit which I would like to call out is that they have a focus both on the development as well as in operation. And one thing which I could say specifically for the people who are not from this background, that SRE is one thing which was introduced by Google, I think way back in 2008, and the entire principle was that they wanted to address this whole challenge between the development team and to the operations team. And how they did this, they created this team like a middleware which basically looks into both. And the way to look at it is that the SRE team responsibility is to ensure that their time is 50% of the time is focused only on the toil. Toil is the technical issues, the operational issues, and 50% is focused on the development, and they have something called as error budget. So if the application availability is 99.99%, then that means that they cannot really approve any changes which can impact their application availability beyond 0.01%, because 100 minus or 100 plus 0.01 makes it 99.99%, right? So that is the basic focus. So those are the changes that have to be done from an organization perspective. From a technology perspective, I think one thing which I said, that the infrastructure as a service or infrastructure as a code is important to build in, and hence you reduce a lot of your time in provisioning your infrastructure for doing any kind of deployment testing or building of those kind of platform. Like for example, I talked about Barclays. So Barclays has really worked on creating, has really partnered with Red Hat to create their Ansible towers, and that's where they've created this private cloud, and hence got all those different features or timelines reduction that we normally get while doing it on cloud. Even now, there are opportunities and options to create such environment even on your private cloud. Maybe things like AWS Anthos, or maybe hyperconverged infrastructure, by using Nutanix. All those things can be really adopted. Immutability, that means you needed to ensure that there is no difference between your between your development and your test environment, and hence you need to ensure that you build one configuration, and then that is what is being deployed everywhere. Microservices architecture, everybody understand that. Continuous delivery is all focused on the code changes are built, tested, and prepared for release, because that's what would be used by your business team for doing that testing. Chaos engineering is a new word. So you basically induce the failure into the system to identify, before it goes to the production release, to identify what can go wrong, right? Think about a Black Friday, right, which was recently being done by a lot of e-commerce. So hence, they would have not really thought about it while they were creating these applications, and hence they need to struggle with. And I'm sure a lot of you would know that Flipkart had a major issues into their application, where the application became non-responsive because they were not prepared for Black Friday, right? So kiosk engineering basically help you to induce those kind of failure situations. And there are organizations and there are tools like Gremlin, Simian Army, which are available to induce those kind of issues into your current development environment, so that you are prepared for that, right? Then AI/ML, we all know the biggest impact of AI/ML is that while you are working on AI/ML, there is a great sense of doing a prediction of how one module has really failed in the past, and how you are able to preempt them and basically visualize them, and then basically induce or rather feed it back to your developers, so that developers identify that these are the issues that they face. This is from the developer standpoint. From the overall project managers who are taking care of the entire projects of an application development, they will be able to identify from their entire days where they needed to deliver a project, where do they see is a bottleneck in terms of meeting their timelines, and hence they can look backward towards it and then identify what to fix, right? So those are a couple of use cases that are important. Distributed tracing, people who are coming from the microservices environment would know that it is typically around the monitoring the end-to-end workflows in microservice environment, right? And there are different kind of solutions like Istio and Jaeger which are available to make that happen. And then last but not least, from a process perspective, there are specific changes. For example, you're talking about policy as a code. So all those different change management reviews that happen, and then you needed to come and do those changes into your code later, they all should be built as a part of the policies, and hence maybe some sort of static code analysis is being done, some sort of unit test success rates and the coverage rates which are being defined to ensure that even that gets automated, right? Single environment should be exist so that you don't have too much of difference. Otherwise, a lot of times when you take that code back to the production environment, one big common issue that we face across is basically that the configuration is not same as into the production environment. And then there is this ultralight change management process, which means your entire policies are being form of a code, and hence you don't have to do a lot of changes into the code. And one word of caution, all these things that we talked about, they really work lot for brownfield and greenfield applications that usually don't really work for legacy applications because of the integration related challenges that we have seen, right? For example, if you try this on a mainframe, then the chances are you might not be able to get a lot of such things because of the legacy architecture that it has, right? So then we would say that amongst everything that we talked about, there are a lot of tools that are available, and I don't want to go through it. Guys, what we plan to do now, I will just give you a short view of how our pipeline would look like. This pipeline that we have used for demo today, there the planning and the issue tracking is being done on Azure boards. Like, you would usually do it on either a Confluence. I remember that you use Confluence or maybe Zira. Then basically you trigger it on the Azure DevOps. And then the trigger of a pipeline would happen through Jenkins. And the coding would be done on your Visual Studio Code. This would then be monitored on the dashboards, or the visualization dashboard that would get configured on Grafana. And then right after you are doing the deployment, then possibly we have proposed that we should have Prometheus, which would then read different performance metrics data, and it would monitor the deployments. And if there is anything which is an anomaly, for example, service consumption goes high and anything of that sort, then that would get that converted into an alerts and notification. This then kind of would form, and all of the codes would basically be into the Azure repos, so that that can be pushed and pulled depending upon the deployment that you're making. And then based on the customer feedback, we can also see the performance metrics on how the new issues can be created into Azure DevOps and how they are being assigned to the developers and the team, and how the cycle continues, right?
And more into the technical aspect and implementation aspect of the theoretical aspect, which we have just gone through. So first, let me put the technological aspect, and let me put forward the plan which we have done in this demo, and I'll practically show it what we have done, so that it will give you an exposure of how this overall pipeline is implemented, and how collaborative these tools are, and how one technology interconnects with another technology so seamlessly. I'm going to show up with a very, very simple collaborative mechanism. And here I have brought in, so without any infrastructure, we cannot implement any kind of pipeline. Obviously, we need infrastructure. So I have used Azure infrastructure as a service for my infrastructure, and the applications, whatever I'm doing here internally, is based on, of course, microservice architecture. So here, I mean, technologically speaking, why microservice architecture is given a preference in this kind of implementation, particularly to make ultra light change management, is things need to be so flexible here, right? So every microservice which we build here should be typically looking at solving a minor issue, so that I can probably easily replicate them, easily load balance them, so that even if one of them fails, I can make the other thing work, and it will not cause a lot of chaos. That is the key issue why we go for microservice architecture, because it might be focusing on a single point. So multiple microservices will be collaboratively working together to actually resolve a bigger issue. And as I told, as far as infrastructure is concerned, I'm using Azure, and overall the policy and other stuff, policy driven CI/CD. So you might be using your process model. In that process model, you might be sticking to a particular process, and in that process, what to be done as part of your DevOps cycle, and who can push the code, and who can run the CI/CD. Is it going to be manual, or is it going to be automated, and what level the testing has to be done? So for this policies and the overall process management, to be precise, I'm using this component called Azure DevOps. So in Azure DevOps, it's a comprehensive DevOps solution basically, It's up to us what part we use it, right? You can just use it for CI/CD pipeline, or you can use it just for repository, or you can use it even for carrying out the entire process. But just to demonstrate the policy aspect of it, I'm bringing in Azure DevOps. And as far as the CI/CD pipeline is concerned, I'm going to use Jenkins. But if something has to be integrated, first of all, there needs to be code, and that code needs to be coming to a repo, right? So even the repository, I'm going to maintain it in the Azure DevOps, right? So there must be a proper tracing for your application, how it is working, whether it is working fine or not, whether everything is available or not, and it must be traceable in a distributed environment. It should not be a client server environment. And once you have enough metrics, there must be analytics in picture. You need to know how the system is performing, and you need to know predict failure, and you need to probably manage chaos, all this stuff. So for distributed tracing, monitoring, as well as analytics, I'm using this component called as Prometheus plus Grafana, which helps us in visualization and as well as getting the overall performance, as well as what is happening in the entire ecosystem, right? So I haven't complicated anything, to be precise. I made very simple pipeline just to show you the flow, and you can convert it into a big picture how the overall real-time environment might span in if you bring in a lot of things. Here I might be explaining it with one simple microservice, but you have to imagine the same thing if it is multiplied, right? You might be understanding the overall effect of it. So I minimize the kind of work which we are doing here to bring in a pipeline into picture, right? So I think I have put forward, again I'm telling, for infrastructure I have used Azure, and for the CI/CD pipeline I used Azure repos plus Jenkins. So I collaborated Jenkins plus this, and you have to understand when Jenkins is running its CI/CD pipeline, obviously the deployment will go to the infrastructure. As I told, the infrastructure is in Azure, right? And when something is happening in Azure infrastructure, probably I need to understand what is happening over there, whether all my servers are up, and whether requests are coming to the microservice, and who is making the request, what is the load, everything. That I can probably read the metrics from this infrastructure into Prometheus, and I read the information which is coming over to Prometheus into Grafana, and I'll be visualizing there, right? And for this chaos testing, that is, if at all, if I'm increasing the load, if I want to test how this behavior is happening overall infrastructure, just for temporary basis, I'm using JMeter, where I'll be making a constant request, multiple requests to the infrastructure, so that I'll see the behavioral change on a live environment with Prometheus and Grafana. So we kept it simple. Let's get into the part and we'll check it out. So as Ashish has mentioned, the same flow. Let me put it once again, whatever I have just discussed for process management, planning, issue tracking, Azure DevOps itself comes up with a component called as Azure Boards. Just I'm giving the theoretical aspect of it. We haven't really emulated the teams and the process actually involves in it, but we can manage the overall flow as far as the workflow is concerned. The current DevOps as well as your process is concerned, you can go with Azure DevOps for planning your application flow as well as tracking your issues, right? And in Azure DevOps, usually what we would do is we'll create an organization, and in that organization you can have multiple projects that are running, and each project will be having a repo associated with it, as well as you'll have pipelines and other aspects, artifacts, everything will be part of it. Within a while I'm going to show you the implementation part of it, right? So here in this implementation, I have just took an Angular application which a developer team would be constantly coding with whatever permissions they have, right? So they might not be having the entire permission to push into the master branch. So with whatever the feature this guy is working, he might be pushing the code into Azure repos. And once Azure repo gets it, the usual process is once it has been pushed into Azure repos, the peer team members has to review it. And once the review is done, probably you might need to go for testing. If everything is done over that particular branch, probably the other guy who has got the proper credential might be pushing into a proper master branch or a deployable branch. From there, the delivery needs to be continuous here. That is, faster delivery is a challenge here. So here we have to understand, usually we schedule the delivery, but as we proceed further, if you infuse this model called as test driven development or behavioral driven development, what happens is in your code you might be writing as many test cases as well as test scenarios as possible in such a way that including load testing, unit testing, integration testing, everything into picture. If it passes every aspect, so you have to improve the testing capability of your system. Once you improve the technical capability of system, obviously we are quite sure that we have assessed everything. We have even analyzed the odds of your system, so that since you have tested, finally you might be pushing to master branch. Then you don't need to actually get into manual process because already we have done enough testing and stuff. So whenever our code gets pushed into master branch, it has to automatically trigger a build by using this CI/CD pipeline. So Jenkins, basically what does it do is it automatically pull the code from Azure repos. Here, of course, we have configured in such a way. And once we build and test our application, obviously it is automatically going to get into our infrastructure. In our case, my deployment infrastructure is Azure. We can also go for containerization. We can deploy in the application in the form of containers, but in this particular demo, I haven't gone through this. So once your application is running in the infrastructure constantly, right, I might be putting my tools over there, which emits various metrics regarding my overall infrastructure, about the server, be it server, or be it the operating system there, be it the microservice which is running over there. I can actually trace everything. This is what I told. Distributed tracing. I can trace each and every aspect of my deployment, and I can constantly gather the metrics, and I can use any kind of metrics gathering tool like InfluxDB or Prometheus or anything of that category. Here we are using Prometheus as the case study. So once I get in my data into Prometheus, automatically I'll be capable of visualizing it by using this component called Grafana. And most importantly, if something which is undesired, or if you might have your own policies, right? So if something is not going according to the policies, you can have your business conditions already employed in place, right? So automatically what you will be doing is you can generate the alerts. Actually in real time, you have to understand, whenever an alert or notification is generated, you might be having some capability to resolve the issue. That is what we really called as in site reliability engineering. We call it self-healing mechanism, where for a particular scenario where you have checkpoints, if something undesired is happening, you might be having a self-healing mechanism. So I can even infuse this. But in this particular flow, I haven't infused it. I stopped the cycle with generating alerts. But this is the overall flow. So let me get into the tools and components which we have put in place. But this is the scenario. See, I have my Prometheus server. Prometheus is a time series database plus monitoring system, which usually gathers metrics from various sources. It might be operating system, it might be databases, it might be cloud. So it is capable of gathering metrics from almost everything. And as I have just mentioned, as a CI/CD pipeline, I'm using DevOps and Jenkins. So the current project in picture is Azure. I already have a couple of auto triggered. Everything is actually auto triggered here. So it's an auto triggered pipeline. And if you look at the configuration here very quickly, I'm not going to get into too much of technicalities, but you have to understand I have made a pipeline that is, it is going to get the code from the repository try through catch at dev.azure.com. It is not getting it from some GitHub or something. As I told, we are maintaining our code in Azure repos, which is part of Azure DevOps. So whenever code gets pushed there, that is into the master branch, not into every branch. And we also have a proper security infused by giving the proper credentials with the API token which you get. So whenever we get the code there, here it will be automatically pushed, and we have written a script in such a way that actually we need to even infuse testing. The testing aspect I have ignored, but in real time, when you're building the cycle, you have to run multiple tests. When each test is through, finally it has to get into the production environment. So I'm putting the code directly into production environment. It's a continuous integration as well as a continuous delivery mechanism. So this is what the configuration that is going in Jenkins. I'll come back to this, but as of now I have just seen what is shown what is happening here. And parallelly, as I was just mentioning, so this is how a typical Azure DevOps environment will look like. So it's a comprehensive solution for the whole DevOps process, right? Right from so in the home page usually is going to have your organization. So in your organization, you're going to have a collection of projects, right? You can create as many projects as you want. So you can get into any of your project. Again, logically speaking, each of your projects can have its own tasks involved, right? So based on your process model which you have infused, right? You might be having your own sprints planned and work items that you have planned and backlogs, things that have not been finished, and you can assign it to the users and you can track it, and you can have a collaborative approach, right? You can chat with your team members and you can change the status of it. So it gives a comprehensive solution for both the process management as well as issue management. And apart from that, Azure DevOps comes up with repo management as well. So for my project, I'm maintaining a repository. Actually, we can have multiple branches, and I might not be allowing my users to access this master branch. A user will be using only his feature branch, and I can control the user permissions, everything here. See, I might be creating my team, so I might be having various roles defined for them, and I might be restricting access to branches. All this will be, this is what we call policy based CI/CD. So we might be infusing various business policies into picture to formulate how our code management has to happen, as well as how this continuous integration and continuous deployment needs to go, right? So I might be giving only stipulated permissions for my contributors, and key aspects only maybe build administrators can perform. So all this I do have options here. See, you find various options here, right from what one can do in boards, what one can do in analytics, what one can do in test planning, right? So I might be assigning the various permissions to my users here. And apart from this, Azure also comes up with, if I say Azure here in this context, it is Azure DevOps. So I can go for building pipeline here itself. But for our case study, I haven't used Azure pipeline here. I have used Jenkins, right? And we can also have test plans infused here and the scripts associated here, right? So all your current artifacts, whatever you have built, you can have a storage here. So this is a complete comprehensive solution for your application. So in fact, you can even build dashboards here just to give a minimal information, but in real time, surely with one comprehensive tool, it might not be addressing all the issues. It has to be basically collaboration of multiple tools. So probably in visualization, one tool might be master, and probably in pipelining, a particular tool might be mastering it. In repo and code management, one tool might be mastering. So it has to be a collaborative approach basically. And one important thing which you have to understand is, I use this word collaborative approach. So this component called Azure DevOps is extremely good in terms of making collaboration with other tools. See, as far as this one is concerned, we have this component called as service hooks, where I can get my Azure DevOps chain integrated with various tools. You can see, you can integrate with Grafana, you can integrate with Office 365, other tools like Trello, Slack. In our case, my need is, if I have something happening in my repo, I need to push my code automatically into Jenkins. Jenkins has to take care of building the application, right? So here I have built an automatic service hook, that is, if code pushed into master branch, as you see here, right, I will be triggering a build trigger, so that in Jenkins it might be triggering a build. So already I have attempted it 5 different times, so it has succeeded earlier. So I can get the trace of what has happened earlier here. So apart from that, where is my overall infrastructure? So to demonstrate this, I have my infrastructure with Azure. I have a virtual machine created. As I told, the apt way is you can go for deploying your microservices in a container form, and you can use Kubernetes kind of container management utilities to install it. But I have chosen virtual machine for my deployment. Look at this. In my infrastructure, already the various servers like Apache HTTP, Nginx is running for hosting my images, as well as Prometheus server is also running over there. And for my API, there is a microservice called JSON server is running, and Grafana is also running. Actually, I should have kept it in a different set of servers, but for this demo purpose, I have kept it everything in one place, which are running, and each are running for a different purpose, right? So ultimately, my code is going to be hosted from the port 80 in the web server, right, which is Apache server, which is running over there, right? So let me come to the code. I have already cloned the code into my local system, and the current user, it entirely depends upon the kind of user who is actually working with the code as well as the repository. So based on his permission levels, he can act on a particular branch. In my case, I'm the administrator. I can even directly put it into the master branch. But in real time, a team member might be having rights over a particular branch, and on other branches, maybe he might be having only the read permission. He might not be having any permission to push the code, right? And once he pushes the code, he need to make a pull request for the next level member, who could probably review his code, and if everything goes through, they might be pushing the code further to the actual technical word is merging the code with the master branch, right? So in this case, for this demonstration, I'm directly, as an administrator user, I'm going to push the code, and you have to understand, I'm making a very small change here. Actually, this ABC INC, right? And let me, already my application is live and running. It's a very simple web application just for demonstration needs. So this is the application which is running on a public IP. Perfect. The API, actually this data is consuming from another microservice, which is running as a microservice, and images are hosted in another server, which is Nginx. So a variety of components are involved here for making this application work. But right now, as far as code is concerned, I'm accessing this application code through Visual Studio Code. So here I'm just going to change only one thing. Let us assume I have change to be done in my view. So I'm making my changes. Let me put INC to corporation. So from my local system, I'm committing this code. I call this particular commit to be UI commit. So I'm directly pushing it to the master branch. My point is actually what would have happened is the code would have been pushed to Azure repos, right? So let me go here. Let me go to Azure Jenkins. Look at this. I didn't do anything. I didn't go to Azure or I didn't go to anything. See here, it's automatically started building my code in Jenkins, right? So the code is pushed to Azure DevOps. And since we have systematically categorized everything, if something gets pushed into master branch, it is automatically triggering my build at. And here is what is very important. In this demo aspect, we haven't brought in, but we have to test each and every aspect of your code, as well as you also need to infuse from performance testing as well. If everything goes through, then you need to go for real deployment. That is what the process which we employ in real time. But for this 20 minutes demo, I just removed that aspects in the flow. But you have to assume that I'll be bringing in the various test cases as part of my DevOps chain before it actually goes for the production. And here this DevOps, this CI/CD chain is built in such a way that automatically once this is done, right now the script has been executed. So if I get into this, I can probably check what has happened in this particular cycle. It has pulled the code from Azure repos, and it has installed all the necessary libraries, and it has built the application. You could see that after building it, it is transporting the code into this HTML. There is some internal error that has happened in thing, but as far as my flow is concerned, I think the code has been deployed. So let me go and refresh it. Look at this. There is zero human intervention here. When something is happening, automatically internally the system is so seamlessly behaving that without any outage of the server, my code has been modified, repushed, and it is available live without any downtime. And it's not a single component as well. It's a collaborated split of various components. So while building itself, you should be properly splitting into various microservices, and we make this application available. So we have seen. So I repeat. So far, what I have explained is the same plan. We have a DevOps ecosystem in picture already, which we are maintaining it through Azure DevOps, and our code repository is managed through Azure repos. As I told, it will be having multiple branches, and I can manage various teams by splitting my code into various branches. And each branch, as a right question is asked now, maybe a particular branch I might associate with a particular infrastructure. In this case, since it is a single pipeline, it is going to this infrastructure, and my pipeline is connecting to this. But in real time, there can be multiple pipelines, and altogether, if a code is pushed to a particular branch, I can reassociate it with some other infrastructure altogether. So no matter how complex it is, you can define various pipelines. Here it is a single chain pipeline, but in real time, it's going to be multi-chain, right? Multiple paths is going to be there, kind of a tree. So far what we have seen until now is, yes, the developer is pushing some code and is getting into the repository. My demonstration, I'm the administrator here. Directly I'm pushing into master branch, and I have associated master branch with Jenkins. And when something is pushed into Jenkins, I have written some script in such a way that I'm passing the code into Apache HTTP server, which is actually deployed in Azure. right? And from here, what I have done is, look at this. I have various processes which are running here. And there is this process called as Apache Expo, right? What does this do? This Apache export is a component. You can assume it to be a microservice. What does it do is, and actually in Prometheus terminology, they call it an exporter. But in a general terminology, I can call it a microservice. What is its job is, it will target your Apache server and it will get various metrics from Apache server, be it the number of requests that are happening, number of objects that is created in Apache, how much memory Apache is consuming right now, whether it is up or not, all those metrics, this guy would be, this particular component would be gathering, right? And in my Prometheus server, I might be subscribing to the information from this. Just in a moment, I'll show you. I'm not going to the technical details of it yet. So if you look at this, just now I have shown you the various things, right? So as of my thing is, I am going to run a job in my Prometheus server, which would be targeting the metrics, which is actually emitted by this service called as Apache exporter, right? So it will export the various metric details about Apache server. In real time, you have to assume that here in the flow, in the DevOps chain, I have shown you only 1, 2. But in real-time deployment, there is going to be n number of components, n number of microservices. From each microservice, you can fetch the information by pointing to the endpoint so that you can pull in some information. Right now, it is pulling information only from Prometheus itself as well as Apache server. But in real time, there can be hundreds of such jobs which are involved, and even you can gather it in a distributed fashion also. All right. So it gathers the information into Prometheus server, and Prometheus will maintain data here in Prometheus server. It's a time series database. For example, I want to check the metric called as whether Apache is up or not. So I can get the information. Apache is up, right? It is showing up 1. And for the past 10 minutes, I can see the status. This is a reading which has been given for the past 1 hour. In the past 1 hour, it has read this many times, right? Sorry, past 10 minutes. Here we have configured in such a way that every 15 seconds, it will be pulling the information from this target, right? So as far as our chain is concerned, in this deployment infrastructure, Prometheus is gathering the information, but how much visibility or how much visualization does it give? How much clarity does it give? The question mark here. It's not so visually pleasing. So I want to create some visually pleasing dashboards into my ecosystem, and I can add some application logic if at all needed. I may want to infer a lot of information from it, so that I can make business decision. Everybody can understand things in the system from their own way. In a manager's perspective, it might be different, and the executive perspective, it might be different, and a developer perspective, it might be different. Since we are gathering all kinds of metrics here, you can create multiple dashboards in various perspectives. But in my example, I have just built out a perspective which talks about Apache. But since you have understood the flow, in the first half you have understood the process, you can actually imagine that we are also bringing in people not only who are part of development, we are also bringing everybody, right from the customer to people in the management, everybody to understand the overall system. And there is a continuous connectivity here between every component, and I'm able to understand how my system is performing also continuously, right? So the chain is so clear, and you can build any kind of complex DevOps chaining here, because each and every component in DevOps world is usually collaborative, as we have already seen. Azure is actually giving some component which can talk with Jenkins, and Jenkins gives a lot of plugins to talk with Azure or any kind of systems. And similarly, Prometheus here talking with Apache server, and Grafana here is talking with Prometheus. If at all needed, it can talk with even Azure, even it can talk with Jenkins, right? So all the tools here in this DevOps world is built in such a way that one can talk with other by using some mechanism, right? We call it usually hooks, service hooks. And now let me get into the Grafana server. Again, I have installed the Grafana server in the same server. On the port number 3000, my Grafana server is running, and I already built the dashboard to save the time. And as I told, I'm not going to give various information here. I made it very simple. I just want to give some insights about the running Apache server only. Okay. So as you see here, I have built the dashboard for Apache by connecting with Prometheus here. Here, if you look at the data sources, I might have established a connection with Prometheus, and I might gather any kind of metric from it. And here, this tool provides you way to build dashboards. The dashboard which we are working here is this one. Look at the information here. The uptime is for the past 2 days it's running, and for the past 24 hours, these are the various Apache accesses that has happened. And you also find the graph for various metrics regarding Apache here: CPU load, the worker status, as well as the current number of requests handled so far. So as I told, you can even check the behavior of the system by using some tools, external tools. As I have just told, I have built a script with JMeter here to hit the Apache server from here by running multiple threads here, so that I think if I run it once, nearly 1000 requests might go. Nearly, I suppose, based on my algorithm, it's 1000 into 10, 1000 requests will go. Sorry, 100 into 10, 1000. So let me run it. So what it is going to basically do is, it is going to give multiple HTTP requests to my application which is running in the Apache, right? And this guy is targeting it. So obviously here you need to find the reflection of the request. So it is meant to be a live dashboard, but you have to understand it makes the request to the server periodically. Maybe you might be finding a slight delay in seconds, but surely it will be reflecting. So meanwhile, before it reflects, see the number within a couple of seconds, you might be seeing the change. Also, what I have done is I have generated some alerts as well, right? So in Prometheus, I'll come back to the visualization before it goes for the next cycle of getting the metrics. Parallelly, in Prometheus, I have built some alert. In real time, you have to understand, you might be monitoring various business policies, right? So it has to be behavioral driven as well as policy driven, to be precise. So suppose if Apache is down, you might be taking appropriate self-healing mechanism, right? Here I haven't written such script, but I have written a condition in such a way that I'll be making a request to this Prometheus server to check the details about this metric called as Apache app. Suppose if the current metric is 0, it will be raising an alert. As of now, the alert is not active because the current metric might be 1 because it is running. It's healthy actually, right? So Apache up. Right now, if it checks 1, it is running, right? So it's healthy. But if at all it fails, automatically it will be raising an alert and you can take an appropriate remedy. Look at this. I told you, right? So I don't need to refresh or I don't do anything. Automatically reflections will happen. So it was 1400 initially. So automatically it is getting reflected here. And how this dashboard is working is it is gathering information from Prometheus. So this is the chain which we are following up, and as and when something undesired is happening, you can build a notification chain so that you can take a remedy for it automatically. For example, what I'm going to do is I'm manually going to already alerts and other things I have built it. It is in place. I'm going to stop the server. You cannot expect the reflections in microseconds because the Prometheus server, it checks for the metrics and it checks for the status only every 15 seconds. Maybe after a minute, if you go and check there, you might see that alert fired.
Hey Vinod, this is Ashish. Just a quick time check. We are almost on the top of the hour. So, can we conclude this in 4 or 5 minutes and then take questions?
Exactly. I'm almost done. 3 minutes. Yeah.
Okay, sure. Thanks.
Yeah, I'm done. Just 3 minutes. This is the last aspect which I'm explaining. Alert. So as I have just told, I go back to this alert. See, earlier it was inactive. That means the check condition which it was checking, it wasn't failing, but right now it has fired, right? So it says Apache down and the event is fired automatically. So we need to build the pipeline and the overall ecosystem in such a way that it is basically self-monitoring and self-healing in nature. And also in this pipeline, I just made a email alert, right? But in real time, you might be taking various remedies for it. But just to say that the alert is working, I just built a email alert, right? Look at this. I have a configured email ID support@trythrough.com, and I got notified that my Apache server is down. So this is how we seamlessly build the mechanism which brings in all the principles which we had just discussed minutes before, right? So, and most of the tools are open source, and most of tools are basically microservice in nature, distributed in nature. You can easily bring into picture and easily you can collaborate with other tools. That's how each and every a tool in each and every level is being built nowadays. So there is no fixed set of tools which you want to use, or there is no particular stack mechanism which you need to follow. Almost every tool is capable of getting connected with one or other tool because most of the tools are open source. It is highly configurable. So this is about the flow which I intended to explain and give you an insight about putting DevOps into play, as well as automating the pipeline and giving information to all, right? So if you see the Grafana, it is not giving information just to developers. Anybody, even a layman, can gather some kind of metrics which he is interested at, right? So this is what it is.